Hello students, in this video I am going to do the differentiation of trigonometric functions. The first order derivative first I will discuss in this video, and in my next video I will discuss about the second order derivatives. Now the first sum is given as y equal to tan inverse of square root of a minus x by a plus x. Now here if you directly differentiate this tan inverse, then the sum becomes quite longer and difficult to find out the simplified value. So what we do is, first we do a substitution to simplify this function. So in this case I am taking x as a cos 2 theta. Now you have to be very thorough with your inverse formulas, inverse trigonometric functions formulas, so that you can understand which this trigonometric ratio you have to substitute. So in this case I am substituting x as a cos 2 theta. So then I am getting y is equal to tan inverse of whole square root of a minus, in place of x I am writing a cos 2 theta whole by a plus a cos 2 theta. Now I am taking this a common, so I am getting 1 minus cos 2 theta whole by a into 1 plus cos 2 theta. So your a gets cancelled. Now we know that 1 minus cos 2 theta by 1 plus cos 2 theta is tan square theta. So I am writing y is equal to tan inverse of square root of tan square theta, which is equal to tan inverse of tan theta. So your tan inverse and tan gets cancelled. So what you are getting, y is equal to theta. And what is your theta? Theta is equal to your, from here I can write theta is equal to half cos inverse of x by a. This is your theta. Okay. Now I will differentiate this. So now this sum becomes, instead of differentiating this whole, here we have to apply the ddx of tan inverse. Then here we have to apply, first we have to differentiate the square root and then the inside part by the quotient rule. So here the sum becomes very easy. So now we will differentiate this simplified inverse function. So now when I am writing dy by dx, now half is constant, ddx of cos inverse is minus 1 by root over of 1 minus x by a whole square. Now since the x has a coefficient 1 by a, so into 1 by a. So now I am simplifying a bit more. So minus 1 by 2a, 2 into a into root over of a square minus x square by a square. So if I take out this a square out the root, it becomes a, and it gets cancelled with this a. So my final answer comes as minus 1 by 2 into root over of a square minus x square. So let me take one more example so that it becomes more clear to you. So sum number 2. Y is equal to tan inverse of whole square root of 1 plus x square minus 1 whole by x. Now according to the values which is given here, we have to substitute x in that way. In the previous one we have taken x as a cos 2 theta, but in this case I will take x is equal to tan theta. So if I substitute x as tan theta, what I will get? Y is equal to tan inverse of root over of 1 plus tan square theta minus 1 whole by tan theta. Now 1 plus tan square theta is sec square theta. So root over of sec square theta gives you sec theta. So it becomes sec theta minus 1 by tan theta. Now this sec theta I can write 1 by cos theta. So tan inverse of 1 by cos theta minus 1 whole by tan theta. So this 1 by cos theta minus 1, I can write tan inverse of 1 minus cos theta whole by cos theta, and this tan theta I can write sin theta by cos theta. So my cos theta gets cancelled. So what I am getting is y is equal to tan inverse of 1 minus cos theta by sin theta. Now 1 minus cos theta, we know it is 2 sin square theta by 2. So in place of 1 minus cos theta, I am writing 2 sin square theta by 2 whole by sin theta, I am writing 2 sin theta by 2 cos theta by 2. So you have to be very thorough with your trigonometric formulas. So your 2 gets cancelled and 1 sin theta by 2 gets cancelled. So what you are left with, y is equal to tan inverse of sin theta by 2 by cos theta by 2, which is equal to tan theta by 2. So you are getting tan inverse of tan theta by 2. So tan inverse of tan theta by 2 gives you only theta by 2. So y is equal to this by 2 I am keeping as half, and theta again I am substituting by x. So it becomes tan inverse x, because we have taken x is equal to tan theta. Now we will differentiate this. So if I differentiate with respect to x, dy by dx is equal to half is constant, ddx of tan inverse x is 1 by 1 plus x square. So this is the answer. Now the sum number 3, y equal to tan inverse of a cos x minus b sin x whole by b cos x plus a sin x. So in this case, we won't do the substitution in the beginning. What we will do is y is equal to tan inverse of, I will divide the numerator and the denominator by b cos x. Now always in the case of tan inverse, we try to keep this as 1. So whatever is here, we divide by that value. So I am dividing the numerator and the denominator by b cos x. So then what I will get, a cos x by b cos x minus b sin x by b cos x whole by b cos x by b cos x plus a sin x by b cos x. Now here I can see my cos x gets cancelled and here b gets cancelled. Here the whole thing gets cancelled. So y is equal to tan inverse of, this becomes here a by b minus tan x whole by 1 plus, now this I am writing as a by b into tan x. So you can see it has changed into the form tan inverse of x minus y whole by 1 plus xy. So that is equal to tan inverse of a by b minus tan inverse of tan x. Now we know tan inverse of tan x is x. So from there I will get y is equal to tan inverse of a by b minus x. Now when I am differentiating with respect to x, dy by dx, now this is a constant. So it will become 0 and ddx of x is 1. So the answer is minus 1. So in all these sums you can see inverse functions. First what we are doing, we are simplifying it and then only we can differentiate. So then the sum becomes easy.